In this part of the video, we are going to look at tangents and areas in polar coordinate systems. Okay, let's look at how we can calculate the slope of a tangent line in the polar coordinate system. Now let's assume we are given r equals f of theta in polar coordinates, x equals r cosine theta, y equals r sine theta, and since r is given as f of theta, I can just plug that in. Now if I'm taking dy dx, I know this is also equal to dy d theta over dx d theta. So that's given. But when I take the derivative of that, I need to use chain rule because f is a function of theta and cosine theta is a function of theta. And I simply do that. And then for the denominator, it's the same thing. You have to do the product rule here. Derivative of first times last plus derivative of sine times first. Those kind of things. Alright. Now, when I go in here, I just copied this from the last page. This is what we have. And if I want to use an example, here's the formula. I just use that example. Let's say r equals 1 plus sine theta. So that's r equals f of theta. So I just plug it in. What is derivative of r with respect to theta, right? And that's going to be derivative of sine theta, which is cosine theta right here. And then the same thing here. So you are supposed to have r cosine theta. And you just put r equals 1 plus sine theta. Just take that here, put it in there, clean it up. You end up with this expression, which is dy dx. Very good. Now what are they asking? Slope of the tangent line 1, theta is pi over 3. So I have the formula. All I have to do is just, instead of theta, put pi over 3. Clean it up a little bit, I end up with negative 1. Alright, well how do I do that with a shortcut in my graphing calculator? You start by setting everything in polar coordinates. Let's go to mode, make sure this is in radian, and this is in polar coordinates. Once you have that, you can go and enter your r, 1 plus sine theta, and when you push this button here, this key, sine of this key, it's going to give you theta. Alright, so you already adjusted it. Now I need to get the value dy dx. Remember, where am I going to get that? Once I have it here, I can go to calculate menu. And do you see that dy dx? It's in there. I can go and pick that up. And it's going to say, well, what value do you want? I want it at pi over 3, so I just go and put in pi over 3. Okay? Then when you push enter, it has to give me the slope, negative 0.999. For all practical purposes, it's negative 1. Very good. Now let's use the equation of the line, and that's going to give me y minus. Now I need the value of y at pi over 3. Well, I can use my calculator for that. Let's go to calculate again. Calculate. I want the values instead of dy dx. So let's push enter. And theta equals pi over 3. So let's get that. Pi over 3. When I push, it's going to give me the x, which is 0.933 right here, and y, which is 1.616, which is here. I use the equation of the line, but now I have it y equals negative x plus 2.549. Remember, I want it on this graph. That means I have it in polar coordinates. Well, I have to go back to polar coordinates. I have to play with this in such a way that I have it in r equals form. So instead of y, I put r sine theta, and instead of x, I put r cosine theta. This is what I have. Now I have the r on the left, factor it out. This is what you have. Divide everything by sine theta, cosine theta. Here we go. R equals that. This is actually the polar form of this equation. I can go and enter that. So when I enter that, I should see the tangent line at pi over 3 at this point, and the curve itself. So let's enter that. So you have 2.549 divided by sine theta, which is here, plus cosine theta, which is here. And close that. And when I push graph, I should see both the curve and the tangent line in here. Now let's look at how we can calculate areas in polar coordinates. This is the formula you need. The derivation can be in your book. The angle going from A, here's A, to B, 1/2 f of theta squared d theta. Now, if we have a situation where I'm trying to calculate one loop of the four-leaved rows, and this is given by r equals cosine 2 theta, you can do it by hand using calculus, and you can write down the integral 1/2 r squared. R is given by that, and just square that going from here to here. Take 1/2 out. And then you have a square. Remember what you do when you have squares. Use the double angle formula. So you get rid of the squares and then split that. And another little trick, you don't have to go from -pi/4 to pi/4. It's symmetric. Just go from 0 to pi/4, multiply by 2. If you put it in there, you get pi/8. Very nice. Well, let's try to do it in our calculator. Make sure you set everything to mode of radian and polar. And the second thing, you go and you enter your r, cosine of 2 theta. When you go and pick polar, when you push this button, that's going to go automatically to theta. Alright, well, let's look at how this graph looks. And you can go from 0 to 2 pi, and then from -2 to 2, from -3 to 3, and then push graph. This looks a little different than this. This is a little elongated because my y-axis is a little different. But nevertheless, I can see that. Now, how do I calculate the area? The area has this formula, and R is given by what I put in here under the R1. So I can go and plug that in the home screen. I can go and say, okay, well, this is going to be 0.5. And I'm supposed to take the integral. For that one, I can use that math integral button. It's right here. Do you see that? Here we go. And now I am supposed to get R1, right? I entered it. I can either enter the R1 in here, or I can just get it from the equation here. So R1, and well, where do you get the R1? You get it from variables, go to Y variables, and let's go to polar. And here we go. R1 is right here. To pick it, you push enter. Then you can square that, and this is a function of theta. What was theta? Theta was this button, comma. Now you are going to go, what are my limits? -pi/4 to pi/4. So it's negative pi, here it is, over 4, 2, comma, pi/4, over 4. Here we go. So this is how you enter it. You enter your R and all this, so you're entering whatever is in here. And then you can put that 0.5 in front of it. And it looks like I got it. And now when you push enter, you're going to get this number, which is pi/8 to start with. And if you don't believe me, let's go and look at what pi/8 is. And it looks like they are the same. Let's say I'm trying to calculate the area enclosed by two curves. For these, you need to almost always have to find the point of intersection of the two curves. And when you do that, you figure out the angles. In this one, it's A, and in this case, it's B. So you're going to integrate A to B. And then this one is the outer f of theta squared minus g of theta squared. You just have to subtract. and then integrate from a to b, and then multiply by 1/2. So you can square them and subtract them, and then very last thing you can do is multiply by 0.5. Now, let's look at a particular case. What's the area that lies inside the circle and outside the cardioid? Okay, so let's draw this thing so that I know. So in here, I first put the circle. Circle is r equals 1. Very good. The cardioid is 1 minus cosine theta. 1 minus cosine is right here. And theta is taken from this button here, the variable button, right here. Okay, so you can adjust the window, but I think I have a good window there, and I'll just push enter a graph here, and then it will draw it. So this is the area that I'm looking for. Okay? Alright, so let's go find it. I know that the formula is I'm supposed to go 1/2. I need to find the intersection points. This is pretty easy, so I don't have to do it. But if you have some kind of funky curves that you don't know the intersections, you can use the calculate the intersection feature. Okay? Here you have, you know this is negative pi over 2 to pi over 2. So that's not a problem. So negative pi over 2 to pi over 2. This is the 1 squared, right? Minus the other 1 squared. Take the difference, d theta, and pretty much calculate the area. So to be able to do that, just remember I put r1, 1, and then r2 here, 1 minus cosine theta. I can get this integral button, but I know that I'm supposed to multiply by 0.5 first, 0.5 times. So you can also enter 1/2 and get the math and go down, and here it is, function integral. So I have the integral. I'm supposed to go and get 1 squared. You know, I entered this as a formula initially, 1 squared minus 1 minus cosine theta squared, but I don't have to do that. Watch what I can do. I can go to variable, and y variable, go to polar, and pick the r1 from here. Do you see that? Then I don't have to retype it if it is kind of a difficult one. Alright, so that's 1 squared minus, what is the other one? r2 squared, so I do the same thing. Go here, and go here, and then go down, polar, and go to r2, pick it up, so I don't have to retype it. Alright, so that is that. Now let's close that. So what I'm going to do, I'm going to put another parenthesis right here. Okay, so second insert, put parentheses here. Very good. So r1 squared minus r2 squared, and put a parenthesis. So that is the quantity. And then I'm going to put down what is it that I need to do, comma. That one is with respect to theta, remember? So theta is right here, comma. And the other thing is negative pi over 2, negative pi over 2. Okay, very good. 2 where? Pi over 2. Here it is, over 2. And then I have a right parenthesis as well. So let's make sure r1 squared minus r2 squared. Very good. Theta, dot, dot, dot. It looks like it may be good. And then when you push enter, it goes and it finds the value. So this is very powerful, so you can use this button. It is under the math menu, and you're all set.